Ways to win, and those 9 ways to win, I'm assuming are listed on this link. Let's take a look. Here they are. Oh, this is perfect. That's the page we need. This is the graphic I actually have in your exam for next week. So you can win if you get all five of the non-Powerballs plus the Powerball. They give you the odds right here. 1 in 175,223,510. You figure that number out today, where that 175 million number comes from. But you can also win if you only get the 5 non-Powerballs, but you goof the Powerball. If you goof the Powerball, you still win $100,000, but the odds go down significantly. And again, we're going to see where that number comes from today. Why it goes down to 5.1 million from 175 million down to that. We'll see that in a second. You could also win if you get 4 of the non-Powerballs plus the Powerball. It's $10,000. There's the odds of that. So here are the 9 ways of winning. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can also see the ways you don't win at all. If you just get 2 of the non-Powerballs without the Powerball, there's no prize for that. If you just get 1 of the non-Powerballs without the Powerball, there's no prize for that either. And if you don't get anything matched, there's obviously no prize for that. So what you're going to be doing in your take-home is actually analyzing the average value of a Powerball ticket based on a certain size of the jackpot, which we're going to use the $590.5 million jackpot that was just apparently hasn't been claimed yet. We're going to analyze the average value of that ticket. So, but what you got to figure out first is I want you to understand how to break down that 175 million tickets up there. So let's swing over to the side board. We'll leave that up there for reference.
No, did you just say we're going to be doing the show and we're going to be analyzing?
Some of the other odds up there. So then there's 9 different sets of odds. There's the odds of the jackpot. There's the odds of just the Powerball, and so forth and so on and so forth and so on. You're going to be analyzing and making sure you can find some of those odds. I think I have you look at one of them. I think I picked 3 non-Powerballs plus Powerball. Why is the odds of that 1 in 12,244.83?
Okay, so we're analyzing the odds.
Exactly. Analyze the odds, and then once you have because all the probabilities are right there.
Okay, right.
If you have all those plus the payout prizes, you can analyze the average value, which is what you'll do at the end.
Okay.
But I want to make sure you understand the extension of where to start today.
Okay.
Cool? Make sense?
I need the verbiage, you know me.
Oh, for sure, for sure.
I need the...
So, Powerball. Let's figure out the total number of tickets that can possibly be bought. You can never actually buy them all, obviously, because you're out of time trying to before the next round. But how many total number of tickets could possibly be bought? This is also tied back to our deal or no deal analysis and why it's impossible to actually analyze every single scenario in deal or no deal. We'll come back to that. Okay, so we're going to set this up like a phone number. We're going to set this up like a phone number. There are 6 spots to fill. So you've got the 5 non-Powerballs. And you've got the Powerball.
Based on these.
Now, if you remember, I don't remember, so I have to look at this. I think it's 59 possible numbers for the first.
1 to 59, we wrote
35? 30, there it is. So our job now is to fill in the other spots, fill in those spots that are right there, okay? So, let's start with something simple, the Powerball itself. How many choices do you have to pick the Powerball? You've got 35. Simple enough, 35. And we're going to multiply down by the time we get to there, which is fantastic. So you can see right away, if you buy 35 tickets, you've covered all possible Powerball options.
Where did we get 35?
It was from their website thingy.
Right. There are 35 possible from 1 to 35 for the Powerball.
Oh, okay.
Yeah. Now, these numbers are selected from 1 to 59. So, how many possibles for the first one?
59.
59. And here's where it gets a little bit, there's 2 twists we have to take. How many for the next one? 58, because you can't use the same number twice. Let me show you a ticket and explain why you can't. Powerball ticket. Image. Where are you? There. That's an okay picture. Let me find a better one. Here we go. Here is, well, ish. Let me make that picture bigger. Here we go. So the reason, take a look at the ticket, and you'll see why you can't use a number more than one time.
Because there's only one little block.
Right. Now, there are actually 5 games on this ticket.
Right.
You would buy, and this is a little bit different than, this one goes to 39 on the Powerball. We're going to ignore that and just go to 35, because that's what my reference has on the Powerball site. But this goes to 59. Once you've picked your first number, you can't pick it again because you've already shaded it out. Does that make sense?
Yeah.
And so this ticket over here is if you buy another ticket, if you pay another $1 to play again. So this is a $5 piece of paper, basically. $1 buys you just this bit. So once you've picked one number, your next number is selected from one of the ones that remains.
Yeah.
Is that fair enough? Good. All right, back over to here.
So then for the second number, you only have 1 in 58.
Yes, well, just say, I love the 1 in 58, and I love that a whole lot, Tiff. But sorry, Lynn. But it makes it easier to just say there's 58 possibles for the next one.
Gotcha.
And then, okay, beautiful. Friends, would you multiply all those together?
Is that what you did to us on the quiz for homework?
Ish. Although those are much nicer numbers.
Yeah, they were pretty nice.
So, what do you get there? And tell me why it's not the same as 175,223,510.
Can we round?
No, just give me all the digits.
Okay.
Is the scientific notation it's giving you?
Yeah.
Oh, here, let's get it down to the here on. Hang on, we'll use Excel.
Okay.
And Sean, do we multiply it by the Powerball as well?
Yeah, everything, because the
Everything
Powerball is
else
part of the ticket.
multiplies.
The Powerball is part of the ticket. Let's do equals 59 times 58 times 57 times 56 times 55 times 35. There we go.
Thank you.
Read those off, friends, if you don't mind.
Oh my gosh.
210.
210.
268.
268.
212.
212.
00.
00. Now, friends, according to the ticket in Powerball, actually, we'll just put this down here. It should be 175 million, not 21 billion. Our number is too big. Why is it too big? And this is very, very subtle, but I want you to understand why it's too big. This is, I love that. That's a great answer, Holly, except for the fact that this is supposed to just be enumerating every possible ticket. So in other words, when you walk up to buy a ticket, your ticket should be one of these. Whatever ticket you end up buying should be one of these. So why did we get too many?
Not purchased.
I love this, Shannon, but that's only going to matter in the average value when I have it on your take home, because they did put 600 million in
Because they're
there.
not
Love that.
purchased.
Scott?
Is there a possibility of like repeats?
That's the problem. We have counted the tickets. Do this for me, friends. Divide that number by their number and tell me what number you get. So take this 21 billion, 26,821,200. Divide it by their number of 175, 223, 510.
120.
Let's go up. Can I make it bigger? No. How do we zoom? I thought you could zoom. Oh, there you go. So divide the two. There we go.
Oh, thank you for doing that.
So if you divide, this is too big. So if we take 21 billion, 26,821,200 and divide it by their number of 175,223,510, what do you get?
120.
120. Is that funny that it came out to such a pretty number like 120?
Yeah.
Some weird decimal.
Something's going on there.
There's a reason why it's 120. Now, Scott, what did you say before? You said a very, very important word.
Repeat.
He said the word repeat. Friends, let's go up to buy a ticket at Powerball, okay? And let's decide right now what numbers we're going to bet on. Okay? So we're going to bet. We're going to bet on. You guys pick.
22,
22,
16,
16,
31,
31,
55,
55,
37. 37.
37, give me a Powerball.
One.
We're gonna put that 1.
Put the 1 in there, good stuff.
Now, I'm gonna go up to the counter, and I'm gonna grab that ticket, pay $1. Grab the $10 first before you grab the ticket, otherwise you get arrested. Give him $1. Give me the ticket. Grab your pencil. What numbers are you gonna shade in first? Which one? 1 first. So you put the Powerball first. So Lynn goes Powerball 1, then goes 22, 16, 31, 55, 37. So when she's done, she's got a ticket filled in that has those 6 spaces filled in. What if Janaea goes in and shades them in order? She goes a 16, 22, 31, 37, 55, and then 1.
Doesn't matter.
Is that a different ticket?
Yes.
No, it's not, because at the end of the day, the same 6 numbers are colored in. It doesn't matter what order you color the numbers in, because when you hand the ticket back to the person at the desk, it looks the same whether you did the Powerball first or the Powerball last, whether you went increasing to decreasing and decreasing to increasing. It doesn't matter. It doesn't matter at all what order you do it in.
So they give you the ticket with the numbers.
That are all empty, and then you grab a pencil and you
But
shade it.
When they print out the ticket and give it to you, the numbers you chose or were on.
They usually put it in order, don't they? I think they do. But that doesn't mean you had to choose them in that order.
Right,
It
right.
just means they put them, and then when they announce the winner, they usually put them in order too, I believe. I
Now,
think.
wait a minute, that only pertains to the 5, not the Powerball, correct?
Well, the Powerball doesn't have an order because there's only one of them.
Right.
So, but the question is it doesn't matter. The first 5, however you decide to color them in, it doesn't matter which one you color first, second, third, or fourth. So what I want to see is if you guys can see some kind of a cool pattern between the number 120 and these 5 possible numbers. And here it is. This is not at all obvious. The Powerball, as Lynn just pointed out, we don't have to deal with the analysis. There's only one of them. So you can't get that in a different order. You pick it or you don't pick it. If you're going to bet on these 5 numbers, how many of them could you put down first or color in first? You're betting on these 5. So in other words, your ticket no longer has 59 possibilities. You're going to bet on these 5. So how many choices do you have for the first one? 5. How about the next one? You can't use the first one, right? How about the next one? How about the next one? How about the next one?
They add up to 20, don't they?
What do they multiply to make?
Oh my gosh.
120!
I mean,
So that explains why we were off by a factor of 120. Because we treated, the fancy word for this, and hear this but don't memorize it. The fancy word for a Powerball ticket is it's a perfect example of what's called a combination, where order doesn't matter. As long as you hand the ticket back with 5 numbers colored in, it doesn't matter what order you color them in. A phone number is an example of a permutation. Because if you dial 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1, you're going to get different people on the phone. Right? Order does matter. That's the slick difference between Powerball and a phone number. Or Powerball and, say, the code to enter your keyless entry for your car or your house. Your little code for your house. I know my number to get in my house has a 5 in it somewhere. That's great. That's fantastic. My friend Amy, she had one of those 4-digit locks on her bike down at Mazama. I know it has a 5 in it somewhere. Okay, that's good. What else do you know about it? I know it has 2 5s in it somewhere. That's even better, because every time she tells me something, I can rule out some other possibility. But that's a permutation because order matters. Scotty?
So if things were different, say like there was only 4 and then a Powerball.
Yes.
Or 5,
4, 3,
could you
2,
just
1.
take all the possible variables of the outcome and divide it by
Yes.
whatever those variables?
Yes, that's exactly correct.
Okay.
So but now that you see it, you know how to deal with it. And Powerball, all you're going to do is you're going to take these outcomes right here, and instead of making it's the too big, you do the correction by simply dividing by the 120, and that fixes it. That makes it have the correct numbers. Maddie?
I just want to make sure I'm following.
Good, please follow.
5, 4, 3, 2, 1. You have 5 options, and then you put down a number, and then you're left with 4 for.
Yes.
That's what you're doing.
Yes.
there? Okay.
Yes, it's the drunks and the coats.
Okay.
It's the drunks and the coats. Except there's 5 drunks and 5 coats instead of 3 drunks and 3 coats.
And what did you say, Scotty?
That basically you take what your possibility, the total number of possible outcomes are, and then you know that you only have 5 balls. You just do that for 5, 4, 3, 2, 1, and you get a number, and then which is 120, and you just divide it, and then you come up with your possibility of winning or your odds.
What we're going to do here is we're going to go down and grab some of the other scenarios and show you how it works in there too. But yeah, the idea, what Scotty's referring to is 100% correct. It's the correction for order. We don't want the tickets to have an order, because when you hand a ticket to the cashier, he or she does not care how you color the numbers in. Just that you colored 6 numbers in, a Powerball and 5. And the Powerball doesn't matter. As Lynn correctly pointed out, there is no order in the Powerball. You pick it.
So it has.
It's not like there's 2 of them and there's 1, 2, 2, 1. It's 1, boom, you're done. But there is an order. When you pick up the pencil to shade in the ticket for Powerball, there are 120 different ways to shade those 5 numbers in. You should not count them as 120 different tickets. That's why you divide by 120. It makes them all go, all the repeats. That's why that word was so, made me so happy, Scott. All the repeats get taken care of and you're left with just the unique tickets. So 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 3. 1, 2, it's going to get really annoying really fast.
Okay, so then, John,
Mm-hmm.
then 21 billion includes his repeat.
Yes.
That's
This
what I wanted to
number,
know, okay.
when you divide that by 120, you get 175,223,510, which does not include the repeats, which are the unique
Yeah, they're not-
tickets.
They're not included.
Those are the unique tickets. Boom.
Ah.
And that's why the chance of winning Powerball is 1 in 175 million-ish. That's why. That's where that 175 billion comes from. Now that you have that, you can deal with all the other odds outcomes. You can deal with all the other odds outcomes, which I'd like to deal with a couple of those situations right now with you guys. Go ahead, man. Ask me that question.
No.
Oh, you just use with me. Perfect.
Good.
So what I want to do is I want to get in there and actually deal with some of the other ways to win and make sure you guys can see where the other numbers are coming from. Is that fair?
Mm-hmm.
So everyone's going on to the next one now, which is not getting the Powerball. You got all 5 of the first numbers, you're like, yeah, but then you get to the end, you're like, crap, I missed the Powerball. You've still made like $500,000 because they're going to take half of that for taxes. But nonetheless, I want you to understand why. I want you to understand why the odds of hitting 5 non-Powerballs and no Powerball is 1 in 5 million-ish. I want you to know where that number comes from, okay? So we now know what the denominator of our probability is because we know how many tickets there are. There are 223,510 tickets. Kate, go.
Don't you just do the same thing minus the 35?
Hang tight. Love this idea. Hang tight, Dave. Okay, good. Hold those ideas, friends. I want to build it from the ground up, though. Is that okay? Because the thing is, you're going to nail this in class today, but when you walk away and then come back to the take-home, it might go back to 0. And I want to have it started from the ground up on the video in case you need the reference. Is that fair, Kate and Gabe? Is that fair? Okay. We'll swing over here. So now, we got to figure out the chance. And the only reason we have to figure this out is because Powerball, when they give you the odds, it's always 1 in, 1 in, 1 in. I would like to see it more, this is my opinion. I'd like to see it more. Every denominator has the 175 million, and then the other number is how many ways you can actually get that. Does that make sense? Maybe not, maybe not. Anyway, let's figure this out. So let's say, what's the chance of hitting 5 non-Powerballs and no Powerball? Now we know they told us the answer is 1 in 5 point whatever, 1 million, 5.2 million. I want you to buy that. I want you to understand why that's the case. Is that fair enough? So now, let's go back to the definition of, time out. We're running further. Does everybody see why the chance of winning the Powerball is 1 in 175,223,000? There's only one winning ticket. There are 120 ways to color that ticket in. Correct? There are 120 ways to color that ticket in, but it's all the same ticket, isn't it? That's the 120. There's always 120 ways to color the numbers of any Powerball ticket in, but they're all the same ticket when you're done. That's why we always divide by that number. Now, sometimes it's not always 120, and you'll see what I'm talking about here in a minute. You'll see what I'm getting at. But you always have to divide by something to make sure that you don't replicate those. That's why I want to kind of go down a list and kind of knock out one by one. Fair enough? Okay, good. Let's do this one first. So, let's do, what's the chance of hitting, chance of hitting 5 non-Powerballs and no Powerball? Okay. So, we know what the denominator is. The denominator is 175,223,510. That's how many Powerball tickets there are. the question I have for you all, how many tickets out there have all 5 of the correct non-Powerball numbers, but the wrong Powerball? Say that again. Is it that many? How many wrong Powerballs are there? How many? There are 34 wrong Powerballs, aren't there?
Yeah.
There are 34 wrong Powerballs. Let's build the tickets. Let's build them, shall we? Let's build them. Let's build them. Let's build them. And here's the Powerball over here. Here's the Powerball. Okay, so you got 5 non-Powerball numbers and the wrong Powerball here. Now, how many wrong Powerballs are there?
34.
34. It's got to be 34 of them. We didn't get the right one. We got one of the wrong ones. There are 34 of them. Now, remember these numbers here? They have to be correct, don't they? They have to be correct. So, how many numbers are there altogether? That are correct in these 5. Oh, good, you guys are applying order. I was thinking there's 5 numbers total, correct? There's 5 numbers that are the jackpot numbers. You've got to get them here, 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 and here. So what I'm doing is I'm taking the order away. Here, you have to divide by each of those, though, to take the order out. So when you guys are saying 1, you're giving me the result of the entire thing. Multiplying across the top like that, we know is going to be too big from our discussion over there. So I'm controlling for that by dividing it here again at the bottom. Now what's the numerical value of all of this? 1. There's only one way to get those first 5 numbers correctly. But you have to get all 5 of the numbers. So, in other words, we're overstating this. How many tickets have all these numbers correct and the wrong Powerball? This is 1 times 34. Because think about it. Suppose the correct Powerball ticket was 1, 2, 3, 4, 5, 1. That was the correct Powerball ticket. Give me a Powerball ticket that has the first 5 numbers right and the Powerball wrong. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5, 4. There's going to be 34 of those, aren't there? Everything that goes 1, 2, 3, 4, 5, and not 1. There are going to be 34 of those bad boys. There are 34 of those out of the 175,223,510. What does that equal, friends? What does that equal as a decimal? 34 over 175 million. No. It's not equal to that. It's a very, very small number. It's a very, very small decimal. This guy's 911. Hang on.
1.94.
Okay, you hold that number. Switch over here.
Which way's the camera pointing?
There we go. All right. So, Powerball tells me the odds are 1 in 5 million.
A little blurry.
100. Oh,
Woo! I thought I just didn't have my glasses right.
that better?
Yeah.
Okay. 5153632.65.
Where'd you get that number?
Yeah, what number?
Off the Powerball ticket. They told me the odds are 1 in 5,153,632.65. You guys are doing 34 divided by, right?
Same number.
Yeah.
175, 223, 510. Notice, it's the exact same number. The only difference is all of their numerators have a 1 in them. Their denominators are changing. What I'm having you do is count it the way we counted that one. So your denominator is the 175 million. But notice, it's the exact same number. The chance of having that happen is 0.000002. 2 in a million. That's what the chance of that happening is. 2 in a million. That's what 1 in 505.1 million is. Which hopefully makes sense, to do the whole 2 in a million. That's all I'm saying. That is a computation of those odds. It shows you where the numbers come from. It doesn't just fall out of the sky. It's because there are 34 possible tickets out of the 175 million that generate all 5 non-Powerballs right and the Powerball wrong. That's it. That's it.
Could you repeat that?
What part?
What you just said.
What,
There
what part
are
of what I just said?
175.
1,223,510 Powerball tickets. 34 of them have the Powerball wrong and everything else correct. So the chance of having the Powerball wrong and everything else correct is just that. Now I calculated it two ways. This way is the way it's stated on the Powerball ticket. This way right here is the way we just calculated it over there. Notice it's exactly the same thing. There's no difference. It's just that when the number drops in front of you like it does on the Powerball ticket, right there, you don't know where it came from. Now you see, oh, I now get why it's there. I have to get all these numbers correct, and then I've got to get that number wrong. That's all I'm doing here. We're analyzing each of these numbers out here. Yeah? Please, Scotty?
Maybe I missed something, but aren't there, realistically, if it's 35 Powerballs and you get it wrong, aren't there 35 chances to get the Powerball wrong?
No, because one of those is right.
But if we don't get any of them right, oh, okay, okay.
You see what I'm getting at, friend?
Yeah.
Yeah, no. Well, I love what you're saying. I love what